start the class.
Okay.
Now, if you recall, you can turn on your video if you're okay.
Sure. Just give me a second.
Sure. Now, sometimes when I'm in a meeting, I will tell people that I'm not video ready. So, if you are video ready, then you can start. You can join. Okay. All right. So, do you recall what all did we learn till the last class?
We learned. I remember asking you SAS, SSA doubts.
Okay.
All that.
Yep.
Then we learned a little bit more about like quadrilaterals.
Okay.
Yeah. And triangle relations, like how each side like could be parallel to each other.
Okay. So we learned about single line segment rays. We learned about angles. We learned about parallel lines. When we learn about parallel lines, that is when we learn about the corresponding angles or opposite interior angles, right? And then we talked about three sides. That is when we talked about triangles, the properties of triangles depending on sides or based on angles. And
yeah.
And then we started looking at the area of a triangle also. Did we? No.
Oh yeah, we did. Yeah. Then there was that formula.
Yeah. And then we talked about the properties of quadrilaterals. That is where we talked about different types of quadrilaterals such as rectangle, square, rhombus, kite, parallelogram, and trapezoid. Yeah. And so in today's class, we will focus on two things. One is we will talk about how do we relate the properties of the quadrilaterals to derive the area and perimeter, and also look at some of the theorems for congruence of triangles and see how that helps us find out the area and triangle. Yeah.
Okay. Yeah.
So let's start with the triangle first and then we'll go to quadrilaterals. So when we talk about triangles, we know all the properties, so we have no doubt with respect to what is an equilateral triangle versus a scalene triangle, right?
Yeah.
And there's no doubt with respect to what is a acute angle triangle versus an obtuse angle triangle, right?
Yeah.
Now let's quickly touch upon the four theorems of congruence. Did we do that already or we did not?
For what?
Four theorems of congruence of triangle.
Yeah, we did that already.
We did that already, so we are not going there, correct? And did we try proving anything or we did not?
I asked you questions about it, remember?
Yeah, you remember. I remember you asked questions about it. But what is important is, do we know how to agree to those theorems? Do we know how to prove those theorems?
I learned it at school.
Okay. So let's spend 5 minutes only. Okay. Let's spend 5 minutes to go through all the theorem. SSS stands for three sides. If there are two triangles with three sides matching, they are congruent. Right?
Yeah.
Meaning, if you are given, let's say, 5 centimeters, 6 centimeters, and 8 centimeters, okay? Three length of the three sides. You can draw only one triangle. You cannot draw two different types of triangles. You cannot have two triangles, one like this and one like this. Okay? If you are given the dimensions. Meaning, if you have three sides given, there will be only one type of triangle that you will be able to draw. How do you draw a triangle with three sides? Let's take one as a base, 8 centimeter. You put a line segment of 8 centimeter, and then you use the compass to draw a circle with part of the circle or an arc of a circle with 5 centimeter, and then from here draw an arc of a circle with 6 centimeter. Okay? And wherever they meet, this becomes your triangle. Okay? So this is 5 centimeter, this is 6 centimeter, and this is 8 centimeter. Yeah? So what I'm trying to say here is, basically, if you have three sides given, you can draw a triangle by yourself, and this is how you will do it. You put one side as a base, the other two sides, you will take the compass with the arc, make a circle, right? You know what a compass is, right? Where you plug your pencil and then draw a circle, right? So you put an arc with one side and put second arc with second side, wherever they meet, join them, that becomes a triangle. So net, what I'm trying to say is, if you have three sides given, you can draw only one triangle, you cannot draw multiple. You can choose this as a base and then you will draw two arcs. But again, you will see the triangles are same. So this theorem doesn't need any proof. You have to, no, this is based on practice. I mean, if you have three sides given, you can draw only one triangle. Okay?
Yeah.
So that's why the first theorem says SSS, meaning if the three sides are same, then they are congruent, meaning every other property will match. Yeah? Now, when you look at SAS, let's say, SAS, meaning there are two triangles where the side and the two angles. So this is angle 1, this is angle 2. This is angle 1, this is angle 2. And this side. If these two sides are matching, then the two triangles will be congruent.
Yeah.
Now look at this. Again the same situation. If you have a side, if you have to make an angle like this, here, make another angle, you will see they meet at only one point. Meaning, if you take one side as a base and then make two angles at the two edges, this will match. Okay? If you still want to prove it, let's look at a situation where I say I have one triangle like this, another triangle like this, where this side and this side are same. This angle is same as 1, but this is not 2, let's say this is 3, meaning this angle and this angle don't match. Okay, but if I make 2 same as this one, and then then only this meets. Or let me put it this way, not this way. Let's say this is your triangle ABC and this is DEF. I'm saying that this angle and this angle are matching between these two triangles. This side and this side are matching, but this angle and this angle are not matching. I'm just hypothetically saying that this is not matching. Where it matches, if I make this angle and this angle same, then it meets somewhere else. Okay? So, net what we are trying to say is, if my side is same, if this side and this side are same, this angle same, then this angle and this angle are not matching. I'm hypothetically saying it, but when you do it practically, when you use a side and make two angles, when you're making two angles, what does it mean? When you're making when you're making two angles here, you will see that when your side is fixed and your angle is fixed, then these two lengths will also be fixed. It cannot change. I cannot say that when this angle is meeting here, then this is same. It cannot be the case. Okay, that it's like contradicting ourselves. So I'm not sure if I'm able to explain this well, but what I'm trying to say is, if I have a side given and I'm making two angles at the two edges, this side and this side's length will be same always. You cannot deny that actually. You cannot, no matter how many times you try, but it has to match. Because your base is fixed and your angles are fixed. So they have to meet at the same point. The length of the two sides will be same. Okay?
The length of the triangle.
Yeah. So basically the length of the two sides, these two sides will match actually. If the angles are same, they will have to match. So that is what this theorem says, SAS, meaning if you're, what am I doing? Oh, my bad. I was trying to prove ASA, this one, meaning the two angles are matching and the side is matching, then these two lengths will be same. Am I confusing you right now? Kind of.
You said ASA, right?
Yeah, ASA basically.
But it's not ASA, right?
Yeah. If your simple thing is, if you have two line segment of the same length, you make one angle, this angle and this angle same. Okay. When you make from here second angle, make the second angle, this angle same here. By no means this length and this length will not be equal to this length and this length. It has to be the same. Yeah. You are doing the same exercise, right? How would it change? Correct? You took a line here, you took a line here. You have drawn angle, let's say 40 degrees here. You have drawn a 40 degree here. If you draw 60 degree here, if you draw 60 degree here, both are same, right? So if you have two angles, you have kept the same. By no means this can be different from this. This is not possible. Correct? This and this cannot be different. It's the same thing. Yeah? Alright. So basically whatever we are doing, this is just to confirm the understanding part of it. Okay, nothing more than that. You will not be asked to prove the theorem, but now similarly SAS, meaning two sides, this side same, meaning this side same, and this side same, and the angle between them also same. Yeah? What will happen? This side will also be the same. Why? If I have, let's say, one side and this side, this angle, if I have this side, let's say this is 4 centimeter, this is 4 centimeter, sorry, let's say this is 5 centimeter, this is 4 centimeter, this is 5 centimeter. If this is 40 degree and this is 20 degree, okay?
Yeah.
So these are two sides, I'm drawing the same thing here, okay? I'm trying to say that this side's length will be the same. Why? Here if you see, if I change the angle from 40 to 20, this length reduced, right? If I keep the length of the side same but increase the angle, then see this distance is changing, right? I made it 90 degree. So I kept this 4 centimeter, this 5 centimeter. So in these three scenarios, what do you see here? Here length of 4 and 5 centimeter, 20 degree. Here 4 and 5 centimeter, length 40 degree. Here 4 and 5 centimeter, angle 90 degree. What is changing? The distance between the lines. Correct? Yeah?
Yeah.
The length of the third side is a function of how big that angle is. Correct? If I keep two sides same and keep playing with the angle between them, what happens? The distance between the two edges changes. Correct? That means if I keep same, this is 4 centimeter, 5 centimeter. Now this one and this side and this side will be same, correct? Because the angle is same, meaning the distance between the two lines will be same, meaning the third side, correct? So look at this picture, this picture and this picture. My two sides length is same, but my distance from between the two corners is changing depending on how big or small my angle is. Yeah? So if the angle is same, the side's length will be same. Right? So that's what happened here. These two sides were same and the angle between them was also same. That means the distance between the two edges will be the same, meaning the third side is also same. So now it again falls back on this first theorem. Now you have two sides same, angle same, that makes the third side also same. So you can say, okay, this is also SSS. So this hence proved. Yeah?
Yeah.
Okay. So I will not go to, okay, I'll still go to this. When this one, the last theorem says RHS, right hand side, right angle triangle, hypotenuse and one side, meaning hypotenuse are matching, these two are matching, and one side is matching, meaning this side and this side are matching. Then they will be congruent. That's what this theorem says. And we also believe in that. Let's say if this is A and C and this is B, this is A and C are matching, right? What is the value of B? A square plus B square equals C square. Let's say this is K. Okay? And this is also right angle triangle. So Pythagorean theorem says A square plus K square equals to C square. Yeah?
Yeah.
So in these two triangles, these two right angle triangles, what we are saying is hypotenuse is same and one of the side is same. So this is C, then this is C. This is A, this is A. This one let's say B and this one let's say K. We are trying to see if these two are same or not. See, from this triangle we see A square plus B square equal to C square as per Pythagorean theorem. For this triangle we see A square plus K square equal to C square. So A is common here. What it means? B square equals K square. That means B equals K. So from this right angle triangle, what you see is this pair of triangle what you see is if the hypotenuse and one side are same, that means the third side will anyways be same as per the Pythagorean theorem. So if all the three sides are same, this also relates to SSS. Yeah?
Yeah.
So the four theorems of congruence are nothing but a means for us to figure out if the triangles are same, if the properties are same, and how there are four different means to prove that. Yeah?
Mm-hmm.
Are you with me?
Yeah, I was finishing up what you wrote last time.
Okay.
Yeah, tell me.
Alright. So now let's go to the next part, which is finding out the area of shapes. This is a right angle triangle.
Yeah.
How much is the area of right angle triangle? Any triangle for that matter, right? We know that it's 1/2 into base into height, meaning if this is base and this is height. Yeah? How you can visualize this is if you extend this, meaning make this line, dotted line parallel to this line, and then from this point again make a line parallel to this line. What do you see here? I made a rectangle by extending this, right? And essentially if you look at it carefully, these two triangles are actually congruent. Yeah?
Yeah.
They are congruent because both are right angle triangles. This hypotenuse is common, right? And this will be equal to this because they are rectangles, right? If you look at this shape, the border if you see here, this is a rectangle and right angle triangle is just half of it. So one way to relate is area of a rectangle is what? Length times width. Or here if I am saying b times h, so I will say b times h. And a right angle triangle is just half of it because when I join the two corners of a rectangle, it splits this into two equal right angle triangles. So area of right angle triangle, or let's say right angle triangle, equals half of the area of this whole rectangle. So half of base times height. Yeah. So all that I'm telling you, it's not something that you don't know. You already know this. I'm just telling you the underlying principle, the concept, how you can visualize this. Because geometry, when you look at, right, it has a lot to do with visualization, how you visualize things. Yeah?
Yeah.
So this is the area of a right angle triangle. Now, I said area of a triangle. Area of any triangle is half times base times height. Why?
Because the quadrilateral it's divided into two, and those two triangles inside the quadrilateral they're congruent to each other.
Right. So simple thing. What you will do is, let's say this is your triangle. Okay. You should always try to make it like a. What did I do? I have drawn a parallel line to the base, right? And here from these two corners again I am trying to draw a perpendicular so that they meet and make a right angle. Make a rectangle. Let's say this is A, B and C. This is a triangle for which you are trying to find out the area. Okay. What I have done, I have drawn perpendicular from all the vertex. Okay. It goes here, it goes here. So let's say it meets at D and this is E. Okay. Now we have a, and let's say from here I am drawing a perpendicular here which is at F. Now you look at this. This triangle has two parts, right? This part and the green part. Yeah. Now this blue part and this green part, these two are again congruent. Look at this is a small rectangle, and again inside that you have a right angle triangle. Yeah. So this blue part is equal to this green part, and similarly this green part that you see, you have a corresponding congruent triangle, right? So this blue part. So this blue part's area and this green part's area is matching. This green part's area and this blue part's area is also same because they are congruent. Meaning if I put that mathematically, I will say triangle AFC is congruent with triangle ACD. The green one is with the blue one. And then same way triangle ABF is congruent with triangle this one. So that is ABE.
Do you mind if I turn my camera off? Because I think your video's a bit blurry, but if I turn my camera off, I can like see.
Oh yeah, I mean that's probably fine, right? It's okay. I mean you can turn it off. It's okay if that helps.
Sure.
Yeah. Is it better?
Um.
Slightly better. Let me bring it a little closer to it. Any
Yeah. Yes. Okay. Yes. Good.
So basically, what I was saying was, you have a triangle. What you do is you draw perpendicular from here, and a line parallel to the base from here, and then this part of the area and this part of the area together is equal to sum of this area, because this is same as this and this is same as this. Yeah. So basically, area of this triangle will be half of the area of this rectangle that you see. And what is the area of this rectangle? This is base and this is the height. So this triangle's area is half of the overall rectangle that you see around it. Yeah.
Yeah.
So this is the reason why area of any triangle is half of base times height. Okay. And in case of right angle triangle, you anyways know you can easily visualize that. So what happens is sometimes we get confused, okay, and that's normal. People will say, okay, if this is my right angle triangle, okay, half into base times height. But here, this is my base. Where is the height? And how does this two formula look? Okay. So that is why I was explaining or helping you visualize how this becomes this. Here you are just joining the two opposite corners. It gives you the rectangle's view, and so you say base times height divided by 2. Here also, if you see, when you extend or draw perpendicular, you are actually drawing a rectangle where this area and this area together is equal to this area that you see in the center. Yeah.
Yeah.
So that is how the area of a triangle is. Half times base times height. Now let's go to the next shape. I want to waste your next 30 minutes telling you the area of a rectangle. Do I need to? No, right?
Please.
So area of a rectangle is base times height, which is very simple. I mean,
Yeah.
length times width. I will not go into that, but if you still want to visualize this, always visualize this. Rectangle is made of those unit or 1 unit squares, and that makes a rectangle. So if I have 5 squares of 1 unit each, so 5 centimeter squares. So if this is 1 centimeter, right? I will call it 1 centimeter square. So I have 5 centimeter squares. Put together 5 centimeter square. If I add 5 more here, it becomes 10 centimeter squares, and this is equal to 5 times 2. If I add one more block, I have 15 centimeter squares. This becomes 5 into 3. So that is how it's length times width, right? So I'm not going into that. Area of a square also you know, so we'll not go into that. Yeah? Area of a square is simple, right?
Yeah.
Again, visualize this as a rectangle. This is length and this is width. Width is also same as length. That's what square says. Yeah, all sides are same. So if you look at this area, it will be length times length, because you don't have width being different from length. It's the same, right?
Yeah.
And you never have to say yes if I'm at all confusing you. Okay.
No, it's okay. It's like a fresh recap.
Right. Now let's look at the next shape, which is my distorted version of the square, which I call as rhombus. What did I do? I had a square and I squeezed it from the two corners. Yeah. So my sides remain the same length, but I don't know how to find out the area of this guy. Do you remember what is the formula for this?
Formula for rhombus. Wait, give me a second. Base times height.
Base times height.
Yeah. Isn't it?
Yeah, base times height could be one way of looking at it. If you take this as a base and you draw perpendicular, find out the height. That will be the same. Yeah, that is one formula. Or another one says half into d1 into d2. Okay?
Diagonals, we were talking about it last class.
Uh,
You were talking about that last class.
Right.
All diagonals and why it's half.
Yeah, so basically this diagonal, this is diagonal 1, this is diagonal 2, they bisect each other at 90 degree. So this, you can visualize this as 4 right angle triangles, 4 same right angle triangles, and 4 times area of this triangle, 4 times area of one triangle. Let's say this is meeting at A, so 4 times area of AOD, let's say. So basically my diagonals are splitting the rhombus into 4 equal right angle triangles. I mean, I'm not trying to prove that. You can very well see that, right? This right angle triangle, both are congruent because this is common, this is matching. So right angle RHS formula, these two are congruent, so the area are same. Same way here and here. Here these two sides are same and this is common, so they are congruent. So this area is also same. Here also, if you see between these two, this and this are common. These are same because they are rhombus, and this is common. So these are congruent as well. Meaning all 4 are congruent. Meaning area of one triangle, if you multiply that by 4, that will give you the area of the rhombus, right? 4 times area of this, which will be half of base into height. So base is, let's say, d2. Height is d2 by 2, because it's half of the whole diagonal, and this is d1 by 2, and that is how you get these two gets knocked off. It becomes half times diagonal 1 into diagonal 2. keeps on getting loud, so I have to keep on blocking it. So this part you anyways know, right? So now you have good that you reminded me that area of a rhombus is base times height, and I cannot deny that. That is correct. Okay. So one is base times height, or if you are given two diagonals, you can multiply the diagonal divided by 2. That will give you the area of a rhombus. Okay. Now that leaves us at a good point. Same way, you can always find out area of kite also. Okay. So if it's a kite, meaning these two sides are matching, this side and this side are matching. Do you know what is the area of kite?
Of kite.
Again, same thing.
No.
Okay, use this A, B, C, D, and this is your diagonal 1, this is your diagonal 2. Okay. Area of the kite is also same as half into diagonal 1 into diagonal 2. You do the same thing. In case of kite also, they meet at 90 degree. They don't divide them equally. They meet at 90 degree. So you will have to look at this triangle and this triangle being congruent, this triangle and this triangle being congruent. So the area of this whole kite would be 2 times area of this triangle plus 2 times area of this triangle, and that will give you this. Okay. So I'm not doing that. If you want me to, I can do that still.
It's alright.
Okay, so this is area of a kite. How about this guy? How do you find out the area of a trapezoid?
Area for trapezoid.
A, B, C, D. What do we know about trapezoid for the first place? They have only one pair of lines which are parallel to each other. That's it, nothing more. Yeah?
Is it like? Wait, I think I learned this. Half it be multiplied by height.
Yeah, it is half into height multiplied by A plus B, where A is one side and B is the second side. Okay?
Yeah.
And do you know how? Would you want me to prove this?
I think I already learned this.
You learned this, so okay. We're not wanting to go there. But there's a very important concept that you might want to consider, that is this. So area of a trapezoid, what I'm doing is, whatever I have here, I'm splitting that into 3 parts.